take this. This has a mass of 1.2 to this E strain to kinetic. Calculate the speed. The kinetic energy is 5.4, so then using EK. Mass is 1.2. So then V should equal to 3 meters per second. The work done. Work equals change in energy. So the change in energy was from strain to kinetic, and that's 5.4. So it's just 5.4 joules. Spring constant, so it's E strain to E kinetic. So the energy for E strain is half K x squared equals E kinetic is 5.4. So then K, the change in this is here given here, 8 centimeters, but we need to convert that to meters because that's the standard units, 0.08. So then K equals 5.4 times 2, 0.8 squared, which is equal to Newton meters. Magnitude of the total impulse. So impulse equals m, change in V. The mass is 1.2. And the change in velocity goes from 0 to 3. So 3 minus 0, which is 3, equals 3.6 Newton seconds. After collision, momentum is 40.4 kg block. Is that greater than it would before? Explain why the greater. Constant. So this is momentum. This has an initial 1. That's 0. That's going in the opposite direction, so it's negative, positive. So I just explained it using the momentum formulas. So since that's 0, that just cancels out. It's 1.2. M1 is here. M2. U1 equals negative plus 2.4. So then as greater initial from the kg to the change is from which is kg block This question, middle is held in stationary. Arrangement stationary and explain your reasoning. So if you resolute all these, you should get B, because this one just goes this way. So it's not going to be stationary. These two cancel out, but it's going to go this way because there's nothing stopping it here. So that's wrong. That's wrong. These two cancel out, but this one is not cancelled. So it's just going to go this way. So that's not stationary. Only 2 marks. The 1 mark is just the B. So explanation would be the direction. Forces. I assume that the magnitudes were the same because the line length looks about the same, so for the middle ring, and yep, that's that question. And next question is question number 4, state the force to the 2 kg sphere in the direction. And the 1 kg. So we're looking at cable A. This is tension. With cable A, there's 2 masses, so we make that into one system, basically. And the force is upwards. So it's going to be so the 2 combined is 3 times. I used 9.8, but you really should be using 10, so it's 30 newtons. To every action is an equal opposite with the weight roll. Identify the corresponding reaction force and give its direction. So we already identified that this is the direction. So we just need to say that. And I talked about how the reaction, it's the opposing force. So the weight force is going down. So the opposing force would just be the tension. question. Oh, this one. So the truck is dragging 2 logs along a level with the retardation force 400 newtons, 600. Calculate the tension. So the only force is the retardation force. So this one, since this we're counting this as a whole system because we're looking at rope 1. So rope 1's connected to both. So we just plus both the retardation forces. So then it's just going to be T equals 800 newtons. Now it's accelerating at 0.5. Calculate the magnitude of T2. So we just look at this system now. So F net equals T2 minus 400. T2 equals M, which is 600 plus the 400. And that should give you 700 newtons. Calculate the speed at the end. So V final at the end of 20. So using SUVAT, we don't know our final. We know initial is 4. S is 20. A equals 0.5. So then V squared equals U squared plus 2AS. V squared equals 4 squared, 16. 2 times half times 20. Root this, V equals 16. 6 meters per second. The ropes have braking force of 2,400 newtons. So rope 1 connects to this. So according to the diagram, this rope is most likely to break because there's more retardation forces. If you just look at this one, there's only 400, but this one has both, so 800. So it's most likely it's going to be this one. So rope 1, it has this, so F net equals T minus the 800. And we know that the total mass is this plus this, if we're looking at it as one system. So 1,200 A equals, and we know that the rope has a braking force of 2,400, so 2,800 A equals 2,400 minus 800 divided by 1200. 4/3 meters per second, which is 1.33. I got the speed at which this leaves Fred's hand. So it has an angle of 60. I'm trying to find initial. It goes up. S vert equals 15. So then you can use B squared equals U squared plus 2AS. When it's up top here with vertical, we're looking at the vertical component. The velocity at maximum is just 0. Initial, we don't know. So we're just going to put U sine of 60 squared plus 2 times acceleration is just, I took it as 9.8, but we can just do 10. And acceleration x downwards, so minus 10 times the distance from here to here is 15. So then 2 times 10, 300. Oh. U squared. Over 3 U equals root 320. This is only the vertical component. We need to find when it's resolved. So U 20 and this angle is 60. So then using the sine 60 20 over U equals 20 over sine 60. So then U equals 20 over sine, which is 23. Calculate the flight time. So we can use this formula to calculate the time. We know when it's at maximum, we can calculate it using half and then times it by 2. At maximum, it's going to be 0. Initial vertical is 20. And then minus 10t. This should be close, I'm pretty sure, to the answer. Yeah. And next question. Calculate the speed before it breaks. Has a braking force of this. So this is centripetal motion. So we know that formula is just mv squared over r. And the braking force, so when this equals the braking force, we need to find the speed. FB is just F braking force. So then that braking force is 4. 4 equals mv squared over r. R equals 1.8. And the mass is 0.2. So then you should get V equals 6 meters per second. P after, it's always going to be perpendicular. So this is going to form a right angle. So then if you just look at that when it's towards the center, it's going to be perpendicular. So it's going to go that way. Another equation, explain why the tension. I feel like for these type of questions, drawing a diagram really helps. And you should take the hint. Use a diagram as part of your explanation because it's 3 marks. So just draw a circle. At the bottom, normal force is greater than the weight force. At the top, at the bottom is greater than, and this normal force is equal to tension. At the top, it's going to point inwards, and the normal force is going to be less than the weight force. So then I just said the tension at the top. I just said according. I labeled this A and B so I can reference it. B compared to point B, compared to point A, point B is greater. Normal force towards the center. Next question. Spacecraft. So we just use these formulas: centripetal motion, using V equal. Just sub that in, and you'll get equals GM2. So then we're solving for the distance. So then R3 equals and the period is here, but we need this in seconds. So then 60 squared over squared. So then R should equal to 6.67 times integral of negative 11. That should equal to but we want to find it from the surface. So if this is the small one and this is my moon, we want to find it from the surface, not from the center. So we have to minus it from radius of the moon. So then that should equal to explain the terms of weightlessness and apparent and identify which term. So weightlessness is you don't feel the effects of gravity. Gravity. Apparent weight. Apparent weightlessness is when normal force equals 0, but the object still feels gravitational force. And then we just need to state next question. Which is the factors? So it's only medium that changes the speed of light. This does not make speed of the observer. No, it's always constant. So it has to be A. None of the best speed of light. It does change. And with this one running away from him, this is running towards. So it's dependent on the medium. If it's going towards, then it will have a greater speed of sound. Running away, you have less, so 335 plus 5 is 340, so we're running towards, so then it should be D. But the light from, because light from traveling slower, no, speed of light is always constant, so you can just take these options already out. Has not yet had time to reach, we need to find that out. So when you find the time, distance over velocity, which is equal to distance here, 10 to the power 25 over speed of light, which is equal to 8.33 times 10 to the power 16 seconds. And if you divide it by 60 all the way till you get years, you should get 2.6 times 10 to the power 9. Question 4, inertial reference. What the following best describes the properties of inertial? So there's no acceleration. No, yeah, so it has to be B because there's no acceleration. There's nothing that says it has to be less than C, because I could say that there is acceleration. Yeah, traveling in a straight line doesn't mean there's no acceleration. Marcus and Morley experiment. Achieve this. I know Michelson-Morley's relates to light, so this is completely off. And was the same as the second. Yep, it was the same. It was not greater or smaller, so you can rule these options out. 6, E total equals EK plus rest. So EK is this one. Rest is MC squared. 9 times 10. Squared equals 2 around 2.4. So this one you just calculated it separately for this and this, so you just do 1 minus v squared over c squared over. And when you sub these values in, to build, you should get 0.88 over 0.36 and 2.44, which is approximately this one. But proper time, the formula for this is this over 1 minus v squared over c squared. Should write a bit further up. L equals LO over. Wait. Let me just write it. Bottom. Yeah. What you get is LO. This is always going to be either 1 or less. This value here is always going to be 1 or less. It's going to be like a fraction. So a fraction times this, it's always going to be less. So it cannot be longer. Cannot be greater. It's going to be shorter than or equal to. Spaceship S. Look at the window. 20. Oh, they gave you this value. So space it's traveling from here to here, and then here. The contraction is always parallel. So when it's shortening, it's always going to be parallel, not perpendicular. It's always going to be either going from here to here, like from here to here. So this one is perpendicular, so that's completely off. This one just doesn't make sense. Like, and should be this one then. 10. We're finding the time. Time equals distance over velocity. Time equals distance, which is 10 over 0.888. 866. C, which is 3.85 times 10 to the power negative 8. C. So 11. Increase students are debating whether special energy projects the mass of gas to increase, remain constant, or decrease. So the mass, the energy, this is going to result in a change in mass, which will increase because the energy is going to convert to mass in special relativity. So it will increase the mass. This one at the speed of this, gamma is this. So I just did applied the momentum, kind of like the momentum thing, but for energy. Momentum equation, but for energy. So then when you reform this formula, you should get, and the change in this should be 1.15 times c squared, which is equal to 6 times 10 to the power of negative 11. And that's the first exam. Second exam is this one. Draw an arrow from point B indicating the direction of the magnetic field. Oh, magnetic field. So positive, negative, this is going this way, going down. So if you put this downwards, applying the right hand grip rule, current is down, so it's going to go outwards to the right. It's going to go like this. And if it's going like that, it's going to go like that. So it's going to be to the right. So I already drew like the line of the magnetic field for here. Since it's going out of this is north, this is south, into here. So if you draw a bar, it's going to go inwards, south, north. It's going to go inwards and then out of this end. So then it's going to be south and north, C. So using the right hand grip rule, positive is going this way, this way, this way, this way. So it's going this, and it is going this way, out of north into south. Using the right hand grip rule, the force is going to be perpendicular to the magnetic field. It's going to go downwards. So if this is going downwards, it's going to go this way then. So then that's going to be B. The current is this, side is this, side of KJ. 6 centimeters, we need to convert that to meters. So we do F L. Number of turns is 50. 50 times 2 times magnetic field 0.05. The length is 0.06, and you should get 0.30 Newton. 30 newtons. Question 3. So we're comparing these two. Oh, peak voltage. The voltage that's used for AC is always VRMS. So always convert it to VRMS. Don't use this because it's not going to work. This voltage is only used for like DC. So like this one. So this one will be correct. Using P equals IV. P and this one, using this formula. You can sub this in to find V squared, to find it in this format. So then P equals 120. I'm using DC, this is DC squared over the resistance 7, which is 2057 watts. Using this one, using the same formula, P equals V squared over R, except V RMS equals VP over 2, which is equal to 106. So then 106 squared over resistance 6 equals to 1872.67. So then DC, AC, so then DC supply, DC supply as the greater supply of power. A farmer uses an AC motor, needs 400 VRMS, so we can just use the normal P equals IV. And that's going to be 950, which is 4.10 to the power 4 watts, which is equal to total resistance. That's the, no, that's not total. That's the motor resistance. Motor resistance in line, VRMS. So we need to find the current. So the total resistance is going to be 7 plus 8, 25. And we know that the voltage is 1000. So using V equals IR, 1000 equals I times 25, I equals 40 amps. Determine whether the pump will operate correctly. So since we know power required is 900 V RMS, we can calculate the power, the voltage required equals 900 V RMS. We can calculate how much voltage actually gets there with the resistance. So V equals IR. So then V loss through transmission lines is through the motor, not transmission lines, through the motor is 18 ohms. So that's the resistance through the AC. So then the V loss is going to be I times R, 40 times 18, which is 720 volts, and this is significantly, not significantly, but less than the required amount. So 100 V, the pump will not operate correctly. Possible, identify the two different. So you can either increase, I talked about increasing the voltage through the transmission lines. Because this decreases the current, which decreases the P loss. Increasing decreases P loss through transmission line. And second change, I talked about how you can decrease the length between, the pump and the AC generator. You could say why, because in P loss you could also talk about transformation, like transformers using transformers, like step up and step down. So then the next one is the frequency. Frequency is inversely proportional to period. So we know the period is 100, but we need to make sure that it's in seconds. So the frequency equals 1 over 100 times 3. So that equals to 10. Calculate RMS voltage. So we can look on the graph. The top is VP. And using this formula, VP 2 equals VRMS. VP is 20, which is equal to, the speed is halved. So as frequency is halved, the period is doubled. Yeah. So looking on this graph, period was from here to here. That's going to be from here to here, because 100 times 2 is 200. And we know that the voltage is going to half as well, so it's going to go up to here. So approximately it's going to be around here, 10. So that's 1, 2, 3, 4, 5, 6. That's 10. And it's going to go here, from here to here. And it's going to reach 150. There we go. It's going to go like this. VRMS is 20, 600, 250. So using N1 over N2 equals V1 over V2. You can flip it so then we can find V2 straight away, but I'll just then V2 equals 5. To a 20 volt. There's no longer, okay. So this is for DC, 20 Vs for DC. We use VRMS for AC. That's why it's not working. In I kind of like to write paragraphs, but you can write in dot point format. And I like to use formulas to prove it. As the voltage is there's not going to be a change in flux. Change in flux. So therefore, no in. So then EMF is not induced. Question. Describe how the magnetic flux changes. So it follows a cos graph, but then the EMF is a sine graph. That's what I like to remember. So then from the top, it's always max. Whenever this is max, this is min. So it starts off max because there's maximum area right now. It's 9. Yeah, maximum area. So I like to be specific. So I say according to figure 6. The magnetic flux is at maximum as it turns, decreases to reach as it continues. Increases in the opposite direction. Average EMF is this 3.6. Oh, quarter. This is really important information. Quarter of a rotation. The number of turns. So we can use the EMF formula. We know that this is equal to BA. This one times this, but this needs to be in meters. So then that's just going to be 0.03. Oops. 0.4 times 0.3 divided by, so there's a quarter of a rotation, and the frequency is this, so then it's inversely proportional to time, period, so then it's going to be 1/2, and it's, since it's a quarter, time divided by 4. Which is equal to 1/8. So then you can sub it in, so 3.6. The top bit you should get 0.03 times 0.4 times 0.3. 0.0036 over 0.125, so then n equals 125. With the commutator, so commutator is used for DC, slip, AC, split is for DC. Shape of the original voltage. You may use a sketch. I talked about how the commutator split ring voltage to flow in one direction. Thus, the voltage only positive, and I drew a diagram. Present this. So I did this. AC. Question 8. Moves from position 1 to position 3. So from here to here. We're looking at flux. So BA. Either this one changes with this one, but the area is the same, so it's going to be this one because it's going from here to here. Steady speed, North Pole. It's going this way. So as it moves, it's going to increase, then it's going to be constant, and then decrease. So then when it corresponds with this, it's just going to be A. The rest just don't make, this is EMF. So that doesn't make sense. This one really does not make sense. We already figured it out that it was D, because it increases drastically, but then once it's like through here, there's no change in magnetic flux, so it's just going to be 0 until it comes here. Like only these points that there's change. So then it'll be either increase, but increase in the opposite direction. Yep. So then it's going to be D. From 2 to 3. Oh, this one was a difficult one because you had to really understand the question, because it's from the South Pole, and if you make it from the North Pole, you'll get it wrong. So from position 2 to 3. So from here to here, read from the South Pole, you may use a sketch to answer. So from going from here to here, so it's going to go from here 2 to 3. From 2 to 3, so it's going to have a lot of magnetic field, then it's going to be 0, so that's going to be like this. That's the change, and according to Faraday's law, it's going to oppose this change. It's going to go to the right again. It wants to increase it again. So then if you use the right hand grip rule, and you hold on to one of these parts, you'll find that, because this is from North Pole, it's going to be from X to Y in the from the North Pole. But then if you look at it from the South Pole, it's gonna be from Y to X. So then according to Faraday. Yes. And 51 can call right and can go east. I'll just 03 11 1965. According to this, using yeah. Now it's just the photoelectric. So energy, frequency of this is this. Calculate the wavelength. So we know that this equals to HF, which is equal to, because F equals to C over this, so then HF equals C over this. Cancel this, so then, and we're finding it in sync, 7.4 times 10 to the power 14. And if you times this value, you get by 10 to the power 9, you should get 105 nanometers. Increases the intensity. Oh, this would support the. Yep. So I just talked about. I linked the question first with the observations predicted. Indicate that carries energy in discrete packets. The metal this supports the model I also just disproved because it says but not the wave model, so I disproved this one. The amount of energy which increases. Emitted this is EK max. So the maximum kinetic energy is just the EK, and EK max is energy minus the work function HF minus this equals 6 point, no, in EV 4.14 times 10 to the power, oops, 10 to the power negative 15 times frequency 2.28, which is equal to 0.83 EV. The stopping voltage equals to the EK max. So therefore V0 equals 0.83 EV. So the next question, the light output. Indicate the number of photons leaving the laser every second. Write down the book. So we need to find the number of photons. We have the energy output per second. So we can find the energy of the photons, which is hc over this equals 6.63 times 10 to the power negative 34 times 8, and then the wavelength is 612 times negative 9. E equals 3.25 times 10 to the power negative 19. So then we have this energy, which is the output, which is the output of input. So over 3.25 times 10 to the power negative 19. So then the joules over joules will count, but this is joules per second. We can just times it by 1 because that's just 1 second. And that will cancel out. So then if we wanted to check our answer, the units should support it. The central band, okay, this is just path difference. At point C, the path difference is 0, which results in constructive interference. And that's the anti and not a dark band. I guess we have to disprove the dark band bit as well. Destructive interference would occur. We know the path difference, so PD equals, but we don't know if it's going to be either this or constructive or destructive. So we have to trial and error. Usually they won't make it that easy, so I just tried and error this one, the node first. And wavelength is this one. Over the wavelength, and that equals 3.5 difference. This value here. So then it has to be a node because of the 0.5. If it was an antinode, it would be a whole number. So then n minus 0.5 equals 3.5, n equals 4. So that's the fourth node to the right. Fourth node to the right is 1, 2, 3, 4. That's x. Okay, original, new pattern. So therefore, this is at node, antinode, and we know that the path difference is the same. So therefore, n lambda equals lambda 1, 2, lambda n minus half. So then this is antinode, and that's going to be 1, 2 to lambda equals, that's going to be 1, 2. The wavelength is 612 times 10 to the power 9 times 2 minus that's 1.5. Lambda is going to be always times by 10 to the power 9 because it's us in nanometers. You're going to get this in meters. 459 nanometers. Calculate the kinetic energy is half mv squared. It's about 5 squared, which is going to be, that's going to be in joules. So make sure you convert that to EV. That's going to be, so then divide by 1.6 times 10 to the power 19. That should equal to 0.064 EV. This one was okay, I guess. Same spacing and that, so they have the same wavelength. So this is the normal formula. No, wait. E over lambda. We need to find this. HMV 6.63 times 10 to the power of -34 over 9.1 times 10 to the power of 31 times the velocity, which is 1.5, and then you sub this value in into this here, and then this value should be, sub this value into here, and you should get the energy, but make sure this is an EV. So and that should be 10 to the power of 8. Oops. $250. Last question. N2, N4, N2 to N4. That's going to be a difference of energy equals 2.6 EV. Using this formula, right over the energy 2.6, which is here, and that should equal to, always remember to times by 10 to the power of 9 nanometers. Discrete quantity not stable. So we always have to relate this to standing waves. So the energy levels, the orbits are specific. Electrons orbit in the form standing So we need to prove why it's only in certain levels, standing waves. Integer multiples. So you can't have half a level. So it's only going to go from here to here. You can't go from here to here. And then wavelengths. And that's it.
Thank you.